Hi, in this video I'm going to solve this equation we have on the center in yellow. I'm going to use the implicit differentiation method. But first, I'm going to, here I have 1, 2, 3, 4 terms that I have to take derivative of. Now, I'm going to copy here in the center the same expression because I'm going to sign, before doing anything, I'm going to sign up what I'm going to do. I'm going to take the derivative of this one first, which is a product. I'm going to take then the derivative of this one, which is a simple term. Then I'm going to take derivative of this one, which is derivative as well as simple term using with a y. And the derivative of a constant will be the last one. Now let's start by the first term, which is this product. So we have to use the product rule. Now I'm going to write it like this. Would be a y to the fifth times the derivative of x raised to the third. So it would be x raised to the third. I'm going to write the derivative with a different color. I'm going to sign it like this. Y would be the prime of this x to the third. And would be here a plus x to the third times the derivative of y to the fifth. I'm going to write first the y to the fifth, and then I'm going to use the same color, the blue one, to sign. I'm going to do this prime. And there it is, and that will be plus the derivative of 3 times x, which I think is pretty easy enough. We can do it right away. The derivative of 3 times x will be just a 3. It will be equal to, here this term, we can as well take derivative just right away. It will be a 24 times y to the second. But here, as we are taking a derivative of a y, we have to add up and attach here this dy over dx. And then we go to the fourth one, which is this one. The derivative of 1 will be just 0. I'm going to write it here so you notice how this converted to, or how this will pass to. So, okay, now let's see. I'm going to take the derivative of the first two. This product over here. It will be, the first term will be y to the fifth times 3 times x squared will be plus x to the third times y to the fifth would be 5 times y to the fourth. But here we have again a y, and we have to add up as well a dy over dx. And then we have this plus 3, and the rest on the right side will just remain the same. 24 times y squared times dy over dx. And we can just forget about this plus 0. It doesn't change anything. So from here, I'm going to add up both sides of the equation, this term on the right, and I'm going to subtract on both sides of the equation this one and this one. So first I'm going to move this one to the right, basically. So this will look like this. I'm going to move to the right this term. It will look like this, the x, the third. I'm going to move the constant to the right as well, because that's the proper way to normally we're going to be working with, times dy over dx. And now I'm going to write this one with a negative sign. Will be negative 24 y to the second times dy over dx. I mean, I'm doing this because we have to solve this equation for dy over dx, just remembering this out. So we got as well this term and this term, don't forget about it. So it will be plus y to the fifth times 3 times x squared plus 3, and this now will be equal to 0. Now I'm going to subtract in both sides of the equation these two terms, so they will move to the right side with a negative sign. So they will look like this. This will be equal to y to the fifth. This is a negative. I'm going to make it bigger. This negative sign, negative y to the fifth times. Oh, here I'm going to do something, because this 3 times x squared, normally you put the x's on the right, on the left, I'm sorry, will be 3 times x squared y to the fifth. And the plus 3 will just switch as a negative 3, and these two other terms will just remain the same. I'm going to actually copy them because I just try to save time. There it is. There we got the same terms, and there it is. Okay, now I'm going to factor out in these two terms this dy dx. I'm going to factor out this one, just in order to solve for dy dx. So this will look like this: dy over dx times, I'm going to use a bracket just because I like brackets here. So it will be 5 times x, this x is cubed, y to the fourth, minus 24 y to the second power. I'm going to close this bracket, and will be equal to negative 3 times x to the second y to the fifth minus 3. And finally, the only thing we have to do in order to solve for the dy dx, we have to divide both sides of the equation by this long term. So the final solution will look like this: dy over dx will be equal to, I'm going to actually, I think it would be just faster to copy this out. There it is. Okay, I'm going to, this will be over, oh, there was a nice line, and will be this term we got here. There it is. And with this, we are done. This is actually the final solution for this implicit derivative. There it is. So hopefully this was useful for you. There was the second example.